Hello, my name is Matt, and thanks for watching this video. This is a walkthrough video to my first Autogram puzzle. It came out in a set of 3, so if you like the puzzle, or you want to try it yourself, or try ones like it, or you haven't seen anything like it, then I encourage you to go dig up the article that it's from, and try it out, and try out its 2 companion puzzles. So, with that, I'm going to start the puzzle. I call it an autogram because the point of the puzzle is to construct an autogram. We were given a sentence with some blanks, and what we have to do is we have to fill in the blanks so that every character that appears in the completed sentence is enumerated correctly within the sentence. Every blank must contain only numerals, and no character appears more than 100 times. So those are the rules, and as we start to look at the sentence, we get an idea of what the puzzle is all about. The sentence is down here, and I'll read it to you. It says, "This sentence contains 49 spaces, 22 commas, 6 A's, 5 C's, 3 D's, 6 E's, 2 H's, 4 I's, 3 M's, 6 N's, 4 O's, 3 P's, 2 R's, 27 S's, 4 T's, blank 2's, blank 3's, blank 4's, blank 5's, 4 6's, blank 7's, blank 9's, and a period." Okay, and so what's missing in this? So some of the blanks are filled in, and it's the blanks for the letters. So how many N's are in the puzzle? Let's just look at this for a second. So there's one N here, and 1, 2, 3, 4, 5, and the 6th one appears in the list, 6. So there's 6 N's in the puzzle, and we could actually go through and look at all of the letters and the totals, and at least for the letters, we know that they're all correct. So there's going to be 27 S's and 49 spaces. If you want to go count up the spaces are here and here, you know. But what we're tasked to do is fill in the blanks for the numbers. And the reason why this is going to become challenging is as we start to fill in the blanks, what we're going to see is that the other blanks are influenced by what goes in those blanks. So say I have a puzzle, say there are 2 7's, then this is going to influence the number of 2's. Right, so maybe now there are 3 2's, then maybe this creates a situation with something, maybe you have 9 9's, for example, where the number of 9's is influenced by the fact that it appears 9 times. Right? So the puzzle play, it's pretty similar to Sudoku. We're going to start by figuring out how many appearances of the characters there are at the beginning, and then we're going to basically work through our options and rule things out and try to apply some math tricks if it comes to that to figure out what goes in the remaining blanks. There's not going to be any guessing. We just have to logic our way all the way through this. And I imagine that there are many different ways to do this puzzle. As I was doing some of the companions, so the companions differ just on the number of 6's. So if you go dig up the second puzzle, what you're going to see is that the sentence is exactly the same, except there'll be 5 appearances of 6. But I imagine I imagine that there's many different ways to do the puzzle. As I was doing some of the companions, I apply other tricks. But for this one, what I'm going to do is, I think the thing that's simplest, I think what we should do is count up the number of current appearances of each letter, and then try to figure out what the possibilities are once the sentence is complete. So right now we have an incomplete sentence. We have to figure out what the character frequency is going to be in the completed sentence. So I'm going to do that. Let's start. I'll make a little grid, and I'll give us... Ooh, if the iPad responds. Yeah. I'll make a little grid here. I'm going to give us 2 working areas for each of the blanks. So a grid with 2 rows and the columns for the numerals. I'll do one for 6 too. There's one for 7. This responds. Great. And what are we going to do with this grid? Well, I'm just going to use it to store the current number of appearances of each character and then the possibilities. So I'll make the first row, I'll call it current. We're going to put the number of current appearances of each numeral. right? And then here are the possibilities. What's really possible? Great. So with that, let's figure out, let's start filling it in. How many 2s appear in the puzzle currently? This is our first question. So currently, let's just count them up. So there's 1, 2 here. 1, 2, 2, 2, there's 2, 3 2s, 4 2s, 5 2s, 6 2s. So currently in the puzzle, there are 6 2s. 6. How many 3s are in the puzzle currently? Currently, there's 1 3, 2 3s, 3 3s, 4 3s. There's currently 4 3s in the puzzle. How many 4s are in the puzzle currently? 1 4, 1 4, 2 4s, 3 4s, 4 4s, 5 4s, 6 4s. I think that's it. I think there are just 6 4s. How many 5s are in the puzzle currently? There's one here. 1, 2. I think there are just 2 5s. How many 6s are in the puzzle? And we know at the end there needs to be 4 6s. But right now there's 1 6, 2 6s, 3 6s, 4 6s. I think that's it. Okay, so now we know that currently there are 4 6s in the puzzle. And at the end, there need to be 4 6s in the puzzle. This means we can't add any 6s anywhere. So this is an interesting fact that I'm sure we're going to come back to. But let's just keep going. So how many 7s are in the puzzle? There's one here, 1 7, 2 7s. And then how many 9s are in the puzzle? 1 9, 2 9s. Great. Great, great. So now we've counted up all of the current appearances of all of the characters. So I'll just erase all of our drawing. And maybe you could go back in time and pause the video and just ensure that I really counted up all of the numerals. Great. But let's figure out what is possible. Ooh, erase some of my numbers. 2, 4, 4. Cool. So let's figure out what's possible. Well, what is the minimum number of 2s that could possibly appear in the puzzle? Minimum number of 2s. I like to start on the left and work right. So what is the minimum number of 2s that could possibly appear in the puzzle? Well, right now there are 6. So it's not going to be the case that at the end of this there are 5 2s, because there are currently 6, right? There might be 16 2s or 25 2s or something like that. But the minimum, definitely the minimum, is going to be 6 2s. And now what's the maximum? What's the maximum number of 2s that could possibly appear in the puzzle? Well, we know that the maximum number of character appearances is 100. And at this point, so we could think, yeah, so let's put in 100. And at this point we can do 2 things. So something I could have pointed out a bit earlier, something interesting, is that there's no blanks for 1 or 0. In fact, there's no blank for 8 either. And if we go and look at all of the characters that appear, or the number of times the characters appear in the blanks that they were filled in for us, there's no 1s, there's no 0s, and no 8s. And what this tells us is that at the end of the puzzle, in the completed puzzle, since every character that appears must be enumerated correctly, it's not actually possible to have 100 2s. The maximum possible number of 2s is 99. So what we're going to do is we're going to go from the left to the right. We're going to fill in all of the blanks for the minimum and maximum number of character appearances. But at this point, we know that the maximum number of 2s is not actually 100. It's 99. And it's 99 because of the fact that we know that no 1s appear in the puzzle and no 0s appear in the puzzle. 99. Okay, so what are the possibilities for the number of 3s that appear in the puzzle? What's the minimum and maximum? Well, the minimum is going to be 4. This is the number of current appearances. And again, the maximum is going to be 99 because there can't be 100. What is the minimum number of 4s that appear in the puzzle? The minimum is 6. It's the number of current appearances. Maximum is 99. Number of 5s, it's going to be 2 to 99. The number of 7s, there's going to be somewhere in between 2 and 99 7s. and the number of 9s, there's going to be somewhere in between 2 and 99 9s. I skipped 6. What is the only possibility for the number of 6s that appear at the end of this puzzle when everything is filled in? It's 4. It's 4 because the blank is filled in for us. Cool. So now we have a lot of possibilities for what can go in this blank, or in these blanks. So what could go in the 7's blank? 2 could go in, 3, 15. Well, 15 can't go in the puzzle because we're not allowed to use a 1, but 25 maybe. 99 seems like it's far too high, because right now there are 49 spaces in the puzzle, right? So it's hard to imagine that the number of the number of 2s is over 2 times the number of spaces. There's spaces all over the place, but I guess it's possible. What we can do now is we can think about, we know the number of current appearances, and we have ideas of where we can put more characters, the blanks. So what we should do is try to take these big ranges and make them smaller, basically. So one thing we could do is we could look at the lower bounds. I'm mostly going to spend time on the upper bounds, but we could just start by looking at the lower bounds and say, is it possible to have 6 2s in the puzzle? Well, it's not. We know that we're not allowed to use the characters 1, 0, or 8, but somehow implicitly we're not allowed to use the character 6. And the reason that this is because of is the fact that currently there are 4 6s in the puzzle, and we know at the end there's going to be 4 6s. What this means is that it's not possible for us to end the puzzle with 6 2s. The minimum needs to be 7. There needs to be the smallest number of 2s possible is 7. There needs to be at least 7 2s. But we only have 6 2s, and we have 6 blanks to fill in, which means in one of these blanks, the character 2 needs to appear somewhere. We can apply the same logic to the 4 blank, because currently there are 6 4s in the puzzle. Our lower bound used to be 6, but we're not allowed to use the character 6 in our solution because they've all been used, which means that the minimum number of 4s is going to be 7. I think that's the most we can do on our lower bounds for now, so let's move to the upper bounds. Is it really possible to have 99 2s in the puzzle? I don't think so. Let's think about where we could put 2s. So I could make this a 22, right? The number of 9s in the puzzle is going to be somewhere in between 2 and 99. This means that it's possible to have 22 9s. And I could put 22 here, and 22 here, and 22 here, and 22 here. And I could even put 22, I could say there are 22 2s, right? And in this case, I would have added 12 2s to the puzzle. So currently, there are 6 2s. I can add, because of these ranges that we've made, I can add 12 more. This means that the maximum is not actually 99, but 18. Because right now there are 6 2s in the puzzle, and I can add 12 more. This means that the maximum number of 2s that appear on the puzzle is 18. But actually, I can't use 18, can I? I can't use 18 because I'm not allowed to use 8. And I can't use 17 because I'm not allowed to use 1. I can't use 10 because I'm not allowed to use 0. What this really means is that the maximum number of 2s that could appear in the puzzle, it's not 18, it's not 17, 16, 15, 14, 13, 12, 11, or 10. It's going to be 9. Great. We just took this massive range of 2s. We knew there were somewhere between 6 and 99 2s in the puzzle, and we reduced it to somewhere in between 7 and 9 2s. But I'm not even allowed to use 8, right? So we now just have 2 possibilities for what can go in this blank. This blank either needs to be a 7 or an 8. So let's go through all of the ranges and just shrink them in that way. So how many 3s are possible in the puzzle? I can't even put a 3 here. I can't put a 3 there. I could put 33 here. I could put 33 here and 33 here. I could put 33 here and 33 here. Okay, that would add 10 3s to the puzzle. Currently, I have 4 3s, which means at the end, the number of 3s would be 14. You know, you have to you have to forget about the fact that we're saying there's 33 and we're going to put 14 in the blank later. But for a sentence that incorrectly enumerates its characters, the maximum number would be 14, but we're not allowed to use 14. We're not allowed to use 10. We can shrink the range, just like 2, we can shrink it all the way down to 9. There is going to be, at the end of this puzzle, somewhere in between 4 and 9 appearances of the character 3. So these ranges are just falling apart. Yeah, so what we're going to do is we're going to basically cut them down and remove possibilities and figure out the numbers. It's very similar to Sudoku in this way, where the blanks are all related to one another, and a valid approach for solving them is to figure out what the possibilities are, and this influences the possibilities in the remaining cells. So how many 4s are possible in the puzzle? I could put a 4 here. I could put 44 here. I could put 44 here, 44 here, 44 here. Okay, this adds 9 4s. I currently have 6 4s. This means that the maximum number of 4s would be 15, but we can't use 15. So just like all of the previous ranges, this is going to shrink to 9. At the end of the puzzle, there's going to be somewhere in between 7 and 9 4s. Currently, there are 6 4s. Okay, so we need to add a 4 someplace else. Erase all these. How many 5s are going to be possible in the puzzle at the end? Well, right now there are 2. I could put a 5 in this blank. I can't put 5s in here or this blank. I could put 55 here, 55 here, and I could put 55 in its own blank. So this would add 7 5s. Okay, there's currently 2 5s, which means that the maximum number, just like the other ones, the maximum number is going to be 9. And I think I'm starting to see the pattern. Maybe you are too. So now on to 7s. How many 7s are going to be possible at the end? I can put a 7 in this blank, and I could put a 7 in this blank. I could put 77 in this blank. I could put 77 in this blank. And I could put 7 in this blank. So that would add what? That would add 7 7s, right? And there are currently 2 7s in the puzzle, which means that at maximum there must be 9 7s in the puzzle. So 9 is the maximum number of 7s. How about 9s? Where can I put 9s? Oh, I don't like that I'm erasing my characters. Where can I put 9s? I can put a 9 here, put a 9 here, 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 and I could put 99 here. This would add what? This would add 7 9s. I currently have 2 9s, which means that the maximum number of 9s is not 99, but 9. Great. Great, great. So where are we? Well, we started with the fact that the maximum number of characters, the maximum number of a single character's appearance is 99. And we use that to build ranges for all of the possible character appearances. 2s, there were going to be somewhere in between 6 and 99 2s. But then we were able to increase the lower bound from 6 to 7, because we're not allowed to add any 6s, and decrease the upper bound from 99 to 9. In fact, we were able to decrease the upper bound from 99 to 9 for every single blank. And what that tells us is that all of the blanks are going to be filled in by a 1-digit number. This is kind of important, because what it means is that there are 6 blanks. 6 blanks we have to fill in. I'll draw them here. 1, 2, 3, 4, 5, 6. We have to fill in 6 blanks. And we know what goes in 2 of them. We know that a 2 must go in one of the blanks because of the fact that currently there are 6 2s, but at the end there needs to be at least 7, so we need to add at least 1 2. And a 4 must go in one of the blanks too, by the same logic. We don't know what goes in the other blanks. There could be several of these blanks could be populated by 2s or 4s. We don't know yet. But we're making progress. What else can we do? Well, we just did a first pass of shrinking the bounds. Can we do that again? So let's go again. Let's see. Is it possible to have 9 2s? Let's start again on the left with 2s, and we'll work all the way to the 9s on the right. So is it possible to have 9 2s? Well, where can I put 2s? I could put a 2 here, a 2 here, and a 2 here. Those are the only places that I can put 2s. When I do this, I get 9 2s. But then when I do that, because right now we have 6 and we just added 3, so once we add those 3 2s, then I get 9 2s. But once I do that, the number of 9s in the puzzle has to increase from 2 to 3. Because right now there are 2 9s in the puzzle. So in order to get to 9 2s, I would need a puzzle with 3 9s. And what that would do is destroy the solution. This would be 3 9s, this would now become 8, this would then become 2 9s. It would be very cyclic like that. We have this contradiction's arisen. But what that means is that it's not possible to have 2 9s, or 9 2s, excuse me, in the puzzle. And it's also not possible to have 8 2s, excuse me, in the puzzle either, because we're not allowed to use the character 8. So what I think we've just done for ourselves is confirmed that the number of 2s that's in the puzzle, it's somewhere in between 7 and 9, but it can't be 8 and 9, which means it must be 7. Must be 7. Let's get a new color. Get a new color. Let's use green. The number of 2s that appears in the puzzle is definitely 7 at the end. Okay, now we've added a 7 to the puzzle, which means we need to do some accounting. There used to be 2 7s in the puzzle. Now there are 3 7s in the puzzle. Okay, this means that the minimum number of possible 7s is no longer 2, but 3. Great, great, great. We've made some progress. We filled in one of our blanks. I'll remove it from the bottom here. Right, so now we just have 5 blanks left, and we know that one of them needs to be a 2 and one of them needs to be a 4. But we don't know which is which yet. We don't know where those go yet. What can I do now? Can I do something similar with another one of these? Sure. So let's just continue moving to the right. Let's look at 3s. Where is it possible to place 3s? Well, I can place a 3 in this blank, and in this blank, and in this blank. We currently have 4 3s in the puzzle. That would mean that the maximum number of 3s, because we're adding 3, would be 7. So it's no longer possible to have 9 3s in the puzzle, but it is possible to have 7 3s in the puzzle. Great. How many 4s are possible in the puzzle now? Currently I have 6. I could put a 4 here. I could put a 4 here, I could put a 4 here, and here. That would actually bring us up to 10 6s. 10 4s, excuse me. But, okay, so maybe we can't shrink that range at all. Guess we can't shrink that range. Let's keep going then. How many, all right, I can't shrink the range for 4 at all. Yeah. Okay. How about 5s? Because currently there are 2 5s, right? So I could put a 5 here. Put it in its own blank. I could put a 5 here. I could put a 5 here, and I could put a 5 here. This would add for us 4 5s. Currently there are 2 5s, which means the maximum number of 5s is not 9 but 6. And remember the fact that if I was to put... Yeah, so in order... Yeah. So currently there are 2 5s. There are 4 more blanks that can accommodate 5s, but one of them is the 5 blank. So is it possible to have 9 5s? It's not. A maximum, there would be 6. But is it really possible to have 6 5s? No, because as soon as I fill that in with a 6, then I would have a puzzle with 5 5s. So actually, at the end of this, the maximum number of 5s is not even 6. It's 5. But it is possible to have 5 5s in the puzzle at the end. I could put in 5s in 7, 9, and 3, for example. Cool. Cool. Let's keep going. How many 7s are possible in the puzzle at the end? Where can I add 7s? I could add a 7 here, 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 and here. So I can add 4 7s to the puzzle. Okay, and this is a situation without a contradiction. So right now I have 3 7s in the puzzle. I could add 4. This would bring us up to 7, and I think this solution would work. The thing that doesn't actually work about this is the fact that I definitely need to include a 2 and a 4 in the solution someplace, and there aren't enough blanks remaining to accommodate those. So I think what we've done there is we've convinced ourselves that the maximum number of 7s that appear in the puzzle is not 9, it's not 8, it's not 7. I think it needs to be 6 by that logic. Okay, so maximum number of 7s is going to be 6. And then how many 9s are possible in the puzzle? I could put a 9 in its own blank. I could put a 9 here. So I can add at most 2 9s, but so what would happen in this case would be the upper bound would shrink from 9 to 4, right? But then now there would only be 1 blank that I could put a 9 in because I can't put 9 in its own blank. What this would mean is that the maximum is actually not 4, but 3. Yeah. Ooh, 3. Great, we just did another full pass. Another full pass. We were able to fill in one of the blanks. We now know how many 2s there are. There are definitely 7. There are 5 blanks remaining. We know what goes in 2 of them. A 2 must appear and a 4 must appear someplace. There are actually only 2 blanks left that can accommodate 2s. So that 2 must go in here and here. Both of these could be 2 at the end. Currently there are 2 9s and 2 5s, so we don't know. Maybe there's a third. Maybe we have to add another 2, but we've made some progress. And let's see. At this point, what should we do? What should we do? Do we start again on the left? Do we make it a little bit more freeform? Let's look and find something. Okay. Well, let's think about this. So there's only 2 possibilities for the number of 4s. This must either be a 7. There must either be 7 4s or 9 4s, because there can't be 8 4s, and we've ruled the range from 7 to 9. And there's actually only 2 possibilities for 9 too. There can be 2 9s or 3 9s. So I don't want to do any guessing, but can we rule out one of these? Like somewhat immediately? Let's say there were 9 4s in the puzzle. Is that possible still? I can put a 4 here. 1 4, 2 4s, 3 4s. So it is still possible to have 9 4s in the puzzle, and this would bring the number of 9s up to 3. But I don't think this works. So this is the only way. What we started with here was we started with 9 4s, because there's only 2 possibilities at the end, 9 or 7. But as soon as we put in 9, we see this contradiction that emerges. All of the blanks are filled in, and we definitely need a 2 in the end. So I don't think this solution works. I think what that means is that at the end of the puzzle, there must be 7 4s. There must be 7 4s. Where did my green go? There must definitely be 7 4s. And what this means also is that there must be 2 9s. So why is this? So 7 4s, the range shrinks. Now no other blanks can accommodate 9s, which means the range here shrinks just to 2. Great. And now that we've filled in some blanks, we need to do some accounting. So what did we add? We added 1 7, so the number of current appearances of 7 is not 3, but 4, and that changes the lower bound to 2. So now there's at least 4 7s in the puzzle, and at the end there needs to be somewhere in between 4 and 6 7s. We also added 2, right? So how many 2s are in the puzzle currently? It's not 6. It's not 6, but it's 7. Great. And that's great because currently there are 7 2s in the puzzle, and at the end there needs to be 7 2s in the puzzle. And what this means is that no other blanks can be 2, right? So now the minimum number of 5s is not 2, but 3. Okay. What have we done? Yes. Yes, yes. What have we done? So now there are only 3 blanks remaining. We use this 2, right? And we filled in one of the other blanks with a 7. One of the blanks definitely must contain a 4. And now we know that one of the blanks must contain a 5 because the current number of appearances of 5 is 2, but at the end there needs to be at least 3. So we have 3 blanks left, and we definitely know what goes in 2 of them. But I don't know which one. I don't know where they go or what goes in the third. So a 4 can go in any of the blanks, and a 5 can go in any of the blanks also. And I think that that is all of our accounting. So what do we do here? What do we do here? We need to, I think we just need to do again what we've been practicing, which is to shrink the ranges a little bit further. So which range do I want to shrink? Well, let's see. What do we want to do? Okay, well, we know that the maximum number of 7s is not 6, because 6 isn't a possible number that we can use anymore. That's a little bit of a layup. It must be 5. 5 is the maximum number of 7s. Okay, now, is it possible? What do we have to do? We have to figure out what goes in the remaining blank, and then we have to figure out where the 4 and the 5 go. Let's look at 3s. Right now there are 4 3s in the puzzle, okay? And I can add one more 3 in this blank. What this means is the maximum number of 3s in the puzzle is not 7, but 5. At the end of the puzzle, there's going to be a number in that blank, and it's going to be somewhere in between 4 and 5. Great. Great, great. It looks like all of these ranges are, you know, there can be a 3 here. There could be a 3 there, but all of the other ranges are just, you know, it's 3, 4, or 5. Those are the only characters that we're allowed to use. What now? I'm not looking at the solution or anything, so I'm doing this in real time with you. What now? Well, we could just look. I mean, if there were... Oh, well, it's not possible to have 5 7s in the puzzle anymore. Because currently there are 4 7s, and none of the blanks can accommodate 7s. What this means is that the maximum number of 7s is not 5, but 4. We've definitely figured out how many 7s go in the blanks. There's definitely 4 of them. This is 4. Great. So now we need to do some accounting. How many 4s are in the puzzle? There used to be 6. Now there are 7. So this all works out. There's 2 blanks left, and one of them needs to be a 5. Okay. 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 We're getting really close. Let's see. Is it still possible to have 5 5s in the puzzle? I don't think so, because right now there are 2 5s, and we can add 2 more, which would be 4, but really we can only add 1 more. We can only add 1 more 5. Yeah, we can only add 1 more 5, and what this means is that the maximum number of 5s is actually 3. And if the maximum number of 5s is, if 3 is the only possibility, then 3 must go in this blank, and then 5 must go in this blank. And I think that's it. For good measure, we can continue with the accounting. So what did we just add? We added a 5 and we added a 3, right? This means that the number of 5s that are in the puzzle at this moment is, the number of 3s that are in the puzzle currently is 5. And And the number of 5s that are in the puzzle currently is 3. But I think the way that we should do this, we should check our solution by counting up all of the characters. Just like we sort of did at the beginning, we should count up all of the characters and make sure that they're all enumerated correctly. So what I'll do is I'll make another layer here. So what does the solution look like? 7, 5, 7, 3, 4, 4, 2. Great. So I'll rewrite it. 7, 5, 7, 3, 4, 4, 2. Let's just make sure I added that correctly. 7, 5, 7, 3, 4, 4, 2. Cool. I can get rid of this layer. And now let's just go through and let's count all the characters and make sure that we've solved the puzzle correctly. So, how many 2s appear in the puzzle? Let's cross them out. There's 1, 2, 3, 4, 5, 6, 7. There are definitely 7 2s in the puzzle. How many 3s are in the puzzle now? There's 1, 2, 3, 4, 5. The last one appears in the list. There's 5 3s. How many 4s appear in the puzzle? There better be 7. So 1, 2, 3, 4, 5, 6, 7. How many 5s appear in the puzzle? There's 1 5 here. 1, 2, 3. How many 6s are in the puzzle? We don't actually need, we don't need to count them up. I'm going to, but we started the puzzle, there were 4 6s, and we didn't add any 6s in any of the blanks, so I think there must definitely be 4 at the end, but let's just count to be sure. So there's 1 here. 1, 2, 3, 4. That's enumerated correctly. How many 7s are in the puzzle? There's 1 here. 1, 2, and then we added 2. 1, 2. So at the end there are 4 7s in the puzzle, and then how many 9s? Here's the last 9. 1 9, 2 9s. Great. And with that, we have created a sentence. We've created an autogram. We've created a sentence where every character that is used in that sentence is enumerated, or its character frequency is enumerated within the sentence. We are happy about that. So, thank you for watching this video. I hope that you go dig up this puzzle and the article that it came from, and you try it out, and you try its 2 sibling puzzles out. It was a lot of fun to make. It was a lot of fun to do, and just as to attract you a little bit more, puzzles 2 and 3, they're exactly the same as the first one. They're practically exactly the same as the first one. They start, this sentence contains 49 spaces and 22 commas. The only difference is, in puzzle number 2, you don't start with 4 6s, but you start with 5 6s. And it just so happens that if you start this puzzle again and you cross out 4 and you replace it with 5, there's a totally new solution. And then puzzle 3, we cross out 5 and we put in 6 6s, and we solve it all over again. And there's a unique solution for all of them. So this was a lot of fun to make. I hope it brings you joy. I've had a lot of fun recording this one, so maybe I'll record the solutions to the other 2 as well. Anyway, thank you for watching. Hope to see you again soon.